everyone, so welcome to Science Age, and what we have today is 6 different liquids in front of me. So I've got honey, maple syrup, dish soap, water, canola oil, and rubbing alcohol. And the water rubbing alcohol, I put food dye inside just so we can kind of see the different colors. Otherwise, it's going to be both clear and you have no idea what you're looking at otherwise. So you're probably wondering, why do I have these many liquids in front of me? Are they for drinking? I don't think so. Instead, we're going to do something called the Tower of Density. Woo, that's so exciting. So normally, if I had more time, I would be adding all these liquids together. But in the interest of time, I've already pre-added 3 of the liquids, honey, maple syrup, and dish soap. And I'll be doing the other 3 here live in front of you. And that's why I have this little thing in front of here, because I don't want you guys to know what happens when you add all the liquids together. And that brings me to my first question for the class. What do you think is going to happen if I add all these liquids together? Any hypotheses? Yes?
I think a rainbow pattern would be formed.
A rainbow pattern. And why do you think that rainbow pattern appears?
Well, I think because the liquids would be lying on top of each other.
Okay, yeah, that's a great hypothesis. Well, what I'm going to do right now is I'm going to start adding the water, and we're going to see what happens and see if that hypothesis holds. Sorry, it's getting a little bit messy on the side here. Can you guys see the top part of it? Can you give me a thumbs up if you can see like the top part of it, of the column? Yeah, maybe I can have that. Thanks, I should have thought of that. Okay, so I'm adding the water. And here's our water, and I'm going to put this back down because now I'm going to grab the next layer, and that's going to be our amazing canola oil. The tool I'm using here is called Turkey Baster. Unfortunately, I don't have any turkey for you guys today, but it is Thanksgiving soon, so hopefully you do have one of these at home. You get to enjoy your turkey. And finally, last but not least, the rubbing alcohol, which is also not blood, even though Halloween is coming up. So yes, it's rubbing alcohol. I can assure you of that. It also has to be very not viscous, so it just pours out very easily, which means I have to be careful to avoid causing a massive spill. I should do it. Okay, there we go. So here is our final product. And so what do we see here? Yes?
Layers.
Yeah, exactly. We see many, many layers. It's almost like a cake, right? Though I recommend that we don't eat it because it's not safe to do so. We have many different chemicals here. And so why do we get these layers? Does anyone have an explanation why we have these layers? Or an idea? Yes?
Some of them are heavy, some of them are very light.
Yeah, exactly. So I'm glad you actually used the word heavy. We have to be careful that we don't confuse mass with density. And that's why, because when we have these layers, it's because of density. It's not because of their mass. And I'll just show you. And so we can see that the different densities of our liquids here are shown to this on this projector here. And honey has the highest density. That's why honey at the very bottom here, and you can see the color of honey. It's this yellow color. It's at the very bottom here, whereas rubbing alcohol is at the very top here, meaning that it's able to float above all the other liquids. And so we can see that it's because of densities that we get these layers of liquids. So now for the next part of this exciting demonstration that I'm sure you're all thrilled to enjoy. So I would like you to make some predictions now. Here I've got 3 objects. I've got this amazingly looking delicious grape in front of me. I've also got a plastic paper clip, and I've also got a ping pong ball. And I want you guys to predict which layer each of these objects are going to fall into. Let's just take a couple of seconds to talk with your table and sort of come up with your predictions. So go ahead, discuss.
What do you think is going to be at the bottom?
Ping pong ball, the grape, and the plastic paper clip.
I think ping pong ball is going to be the green. The grape. I think like right above the
If you already have your predictions, maybe just give me a thumbs up. Okay, perfect. Does someone want to give me some predictions? Yeah?
We think the paper clip is going to end up in the dish soap layer.
Okay, and what about the ping pong ball and the grape?
The ping pong ball, we think is going to end up on the top layer, like floating on the water, and we're unsure about the grape.
Okay, well, let's have a drum and let's see what happens. Let's start with the paper clip. Oh. It's at the very bottom. There it is. And let's do the grape now. Drum roll again. So in the dish soap layer. And finally, ping pong ball. Great job. So you actually predicted the ping pong ball correctly. And I want to just touch on one more thing. So the reason why we get these different objects in these different layers is because of the particle model of matter, which we covered last class. Recall the first and third points. All matter is made out of tiny particles that we can't see, and the third point is the particles have spaces in between them. So this ping pong ball here, it's pretty hollow, so it doesn't have as much space. So it has more space inside, which means the particles are better spaced out and they're less tightly packed, leading to that lower density compared to, say, the grape or the paper clip, which is more tightly packed with particles, and that causes a higher density, which means it falls to a lower layer. So thank you for watching this. What we're gonna do is I'm gonna give you a worksheet for you to revisit those concepts we covered today in the demo. And you also check out these websites. And the reason why is because I want you to think about one thing. The thing is that if we changed the density of an object, that same object in the same liquid, how would that affect their ability to float? And I don't want you to answer that right now. I just want you to think about that because we're going to cover that next class when we go into our next topic. Thank you so much.